आपका ग्रुप कौन सा है? 82 ना?
मॉर्निंग सर।
गुड मॉर्निंग, गुड
गुड मॉर्निंग सर।
मॉर्निंग।
गुड मॉर्निंग
एट
सर।
12 सर।
आपको मैं एक
मॉर्निंग सर।
स्क्रीनशॉट भेज रहा हूँ। राइट, सौरव को भेज देता हूँ। राइट, एंड योर ग्रुप डीएमई जो था, डीएमई मंजीत को इस नाम से था। सौरव, आपको मैंने एक अभी भेज रहा हूँ मैं। राइट,
यस सर।
उसमें क्या है कि जो बच्चों ने वो फाउंड्री का, राइट,
यस सर।
ये भी किया हुआ है। लिंक मतलब जिन्होंने वर्ष फाउंड्री का मैन्युअल से अपने एक्सपेरिमेंट फाइल में लिख के जमा किया हुआ है, उनका नाम मैंने दिया हुआ है आपको। ओनली 7 स्टूडेंट्स हैव बीन सबमिटेड। राइट, जो प्रैक्टिकल है, प्रैक्टिकल फाइल में लिख के जमा किया हुआ है। राइट, ओनली 7 स्टूडेंट्स
सर एक्सटेंड कर दीजिए डेट सर, बच्चे कह रहे थे फिर ऐसे तो।
हैं। अरे,
एक्सटेंड।
फिर लास्ट में क्या करोगे? लास्ट में दिक्कत आएगी, प्रॉब्लम ये होगा।
सर
तो
आप
संडे
एक
तक
वीक
कर दो।
एक्सटेंड कर दीजिए, नेक्स्ट वीक में सबमिट कर देंगे बच्चे
एक वीक
सारे
तक।
सर।
अच्छा, तो इसमें 66 स्टूडेंट्स, टोटल कितने हैं आपके उसमें ग्रुप में?
75 सर,
75 है
75।
ना?
यस सर।
सर
तो
आज क्लास के
ओनली,
बाद सबमिट कर। सर क्लास के बाद सबमिट कर सकता हूँ सर, वो 12 बजे तक की डेडलाइन थी।
हाँ, 12 बजे तक की डेडलाइन है। मैं जस्ट इन्फॉर्म कर रहा हूँ। राइट, 66 स्टूडेंट ने ये एडमिट किया हुआ है यहाँ पे।
यस सर।
टोटल कितने हैं?
सर 75 है सर, मैं बाकियों को भी कह दूंगा क्लासरूम ज्वाइन कर ले।
हाँ हाँ, ठीक है।
सर
क्या
आप
लिखना है,
एक।
क्लियर है ना इसमें?
यस सर, वो तो हो जाएगा सर।
सर थोड़ा एक्सटेंड कर दो ना।
सर
हाँ,
आप
एक
एक वीक
सेकंड, अभी मैं
एक्सटेंड कर
अभी
दीजिए, फिर
अभी
सारे सबमिट हो जाएंगे।
अभी मैं कर दूंगा। बाद
कर
में
दो।
फिर मुझे और जो जल्दी किया हुआ है, दैट दे विल कैरी गुड मार्क्स। उनको अच्छा मार्क्स मिलेगा, नो डाउट।
सर 6 ही बच्चों ने किया है सर, एक वीक एक्सटेंड कर दीजिए सर प्लीज।
सर डेडलाइन तो सर 12 बजे तक थी आज रात।
हाँ, 12 बजे तक की है। अभी मैं, चलो मैं इसका वेट कर लेता हूँ, बाद में फिर ये कर लूंगा, एक्सटेंड कर दूंगा 1 वीक के लिए। राइट। और दूसरा, मुझे
सर
आज जो फोर्जिंग का है, वो उसका मैनुअल मैं आपको भेज रहा हूँ। अपने किस ग्रुप से बनाया था? ME101B। राइट, CR को भी भेज। राइट, तो आपके 101 ग्रुप है, उसमें मैंने आज का जो स्मिथ शॉप वाला मैनुअल है, मैंने भेज दिया है। राइट, एक बार चेक कर लो आपके एंड पे। तो क्लासरूम पे भी मैं पुटअप कर देता हूँ। ओनली 47 स्टूडेंट्स। ठीक है, मिल गया ना आपको?
यस सर। सर मैं पिछली क्लास आया नहीं था और मैंने सर आपसे क्लासरूम में पूछा था कि सर किस चीज़ के बारे में है, सर उसी दिन पूछा था, जवाब ही नहीं आया।
देखो, ऐसे अब
फिर उसके
हर
बाद मेरे को सर
स्टूडेंट्स
बच्चों से
प्रेजेंट
पता
नहीं
करते
होगा,
करते कल
तो
परसों पता
आप
चला
ग्रुप
क्या है।
ग्रुप ग्रुप में हो ना, आप ग्रुप में हो ना, व्हाट्सएप ग्रुप में।
सर मैं पता करते करते मेरे को बहुत लेट पता चला ना सर, अब तो मैं अभी भी लिखना शुरू करूंगा तो सर हो नहीं पाएगा, तो फिर आप कह रहे हो मार्क्स कम मिलेगा, मतलब
नहीं
लोग
नहीं,
लेट ज्वाइन
जिन्होंने किया
करेंगे।
उनको अच्छा मार्क्स मिलेगा, मैं ये बोल रहा हूँ। जिन्होंने नहीं किया उनको मार्क्स कम मिलेगा, ये नहीं बोल रहा हूँ। जिन्होंने सबमिट किया हुआ है उनको अच्छे मार्क्स मिलेंगे। जो नहीं किए हुए हैं, जिनका प्रॉब्लम्स है, मैं ये 1 वीक एक्सटेंड कर रहा हूँ।
पर सर ऐसे क्वेश्चन पूछेंगे आपसे, मतलब आप तो फिर जवाब ही नहीं मिलेगा।
कैसे?
मतलब जैसे आपसे कोई क्वेश्चन पूछना हो डायरेक्टली, मतलब ऐसे तो पूछना होगा नहीं कभी, मतलब
नहीं नहीं,
मतलब
व्हाट्सअप मुझे व्हाट्सअप कर दो। व्हाट्सअप कर दो,
क्लासरूम में
क्योंकि
नहीं।
क्लासरूम, नहीं नहीं, देखो मुझे कोई प्रॉब्लम है तो मुझे डायरेक्टली व्हाट्सएप कर देना। राइट। क्लासरूम का क्या है कि क्लासरूम पे लिखोगे, दैट विल गो टू माय ईमेल आईडी।
सर जो आज सबमिट करेंगे उन्हें भी एक्स्ट्रा मार्क्स मिलेंगे?
एक्स्ट्रा मार्क्स नहीं, जो है वो मार्क्स मिलेंगे जिनका लेट हो जाता है, कोई इश्यू है 1 वीक के अंदर, मैं सबका कंसिडर कर लूंगा। राइट।
यस सर, 1 वीक एक्सटेंड कर दीजिए सर, सारे सबमिशंस हो
हाँ
जाएंगे।
हाँ सब, मैं एक्सटेंड कर रहा हूँ सबका वन
ठीक है
वीक
सर, ठीक।
राइट।
थैंक यू सर।
क्योंकि कुछ लेट कमर्स भी हैं, राइट, जिनका रजिस्ट्रेशन लेट हुआ है।
सर क्योंकि डेडलाइन रात तक की थी तो मैंने पहले सबमिट नहीं किया था।
अच्छा ठीक है, कर देना वो तो, उस पे ऊपर डेडलाइन आज रात के 12 बजे तक है।
सर
राइट।
ये जो आपने मैनुअल भेजा है इसे भी लिखना है?
हाँ, इसे भी लिखना है। राइट। मैं जैसे इसका तो अभी टाइम है आपके पास, राइट। दो कितने 3 वीक्स होंगे आपके पास,
ओके
तो
सर।
आप थोड़ा थोड़ा लिखना चालू कर सकते हैं। अ, तो आज आपका स्मिथ शॉप है, तो
सर ये वाली मैनुअल तो पिछली वाली मैनुअल से भी ज्यादा बड़ी है।
देखो कितना है, अभी स्टैंडर्ड है इसमें, देखो 12, कितने पेजेस, हाँ 21 पेजेस हैं।
सर कितना टाइम मिलेगा?
3 वीक्स है आपके पास।
कितने?
3 वीक्स।
अच्छा 3 वीक्स में करनी है, फिर ठीक है सर।
हाँ हाँ, इसके लिए राइट।
ओके सर, ओके सर।
सर जो आज रात तक सबमिट करेंगे उन्हें भी एक्स्ट्रा मार्क्स मिल जाएंगे ना?
हाँ, वो सबमिट करो जल्दी से जल्दी, तो दैट आई विल कंसीडर। राइट। कभी मार्क्स आपके कम हो जाते हैं, दैट आई विल कंसीडर दैट दिस स्टूडेंट्स इज राइट, अप टू डेट, तो वो मार्क्स मिल जाते हैं। राइट। तो आप हर दिन लेट करोगे तो लास्ट में जाके फिर वो मार्क्स बिल्कुल कम हो जाते हैं। राइट। तो टाइमली टाइमली सबमिट करते रहो। राइट। तो वो फर्स्ट है तो इसलिए मैं 1 वीक एक्सटेंड कर देता हूँ। राइट। कोई प्रॉब्लम नहीं।
सर जो अभी आपने मैनुअल भेजे सर, उसमें लास्ट में क्वेश्चन है सर, उन्हें सोल्व भी करने हैं।
हाँ, लास्ट में जो प्रॉब्लम है, एक्सरसाइजेस हैं आपके, ये आपके एक्सरसाइजेस हैं। राइट। तो वो आपको लिखना है, सॉल्व नहीं करना है ये। राइट। ये एज इट इज आपको पुट अप करना है। राइट। दे आर ओनली द कैलकुलेशन, थोड़ा सा कैलकुलेशन पर्पज है, वो अंडरस्टैंड करना है आपको। और
सर
वो
इस सब्जेक्ट का भी सरप्राइज टेस्ट होता है?
यस,
मतलब इसका वर्कशॉप का भी सरप्राइज टेस्ट वगैरह होता है?
वो देख लेंगे हम। सरप्राइज टेस्ट का, सरप्राइज टेस्ट बेसिकली लैब्स में नहीं होता है। राइट। तो मैं वो बढ़ के बता दूंगा आपको। राइट। ठीक है। हम्म, तो ये आपका स्मिथ शॉप है। स्मिथ शॉप में आपने बेसिकली क्या करना है कि जो आपका रॉ मटेरियल होगा, राइट, इनका फाउंड्री, योर रॉ मटेरियल विल बी योर स्क्रैप मटेरियल, राइट, दैट यू हैव टू मेल्ट इन अ फर्नेस, right, that you have to pour in the mold, right. But in smith shop, right, you are having the sheets or rods, right, and then you have to give different shapes, right, whether it is a open die forging or closed die forging, right. एक मिनट कोई,
Good morning,
जी
sir.
आए हैं विजेंद्र?
Yes, sir.
हाँ,
Yes, sir. Yeah, I'm Vijender, sir.
तो आप कैरी फॉरवर्ड करोगे इसको?
Yes, sir. From now I will carry forward, sir. Thank you, sir.
गुड मॉर्निंग विजेंद्र सर।
Very good morning to all.
Good morning, sir.
Good morning, sir.
Good morning,
Good
sir.
morning.
Good morning, sir.
Good morning. So you can see the screen?
Yes, sir.
Okay. So today's shop is our smithy shop that we will learn about smithy or forging shop. Okay. So smithing is a very common practice since long time. It is used to shape or form metals at very high when the material is taken at very high temperatures. We generally take the forming increases when we increase the temperature of the material, so we can very easily give any desired shape as seen here, and it is very you might have also seen it at various local shops and workshops, right? So it's not a very new concept for you, but to understand in the concepts of engineering, the products made of forging is of very high economic value because it is used in various sectors like automobile, aerospace. In automobile, you can see the forged parts, the crankshaft, connecting rod. These all are made of through forging or smithing process. So introduction is basically forging or smithing is the process of shaping metals by applying a very high pressure or impact through hammering or through presses, mechanical presses. So the metal is generally squeezed to desired shape. This requires the metal to be in plastic state. Plastic state is the state when the temperature is increased to a certain limit, plastic temperature. We will see later in the following slide that what is the temperature of different metals that are required to attain the plastic state. For example, aluminium might reach the plastic state at 400 degrees Celsius. But if you heat the stainless steel as 400, it will not achieve that required temperature. For that steel, it is higher up to 900 or 1000 degrees Celsius. So it is very necessary to take the metal at the plastic state or heated state, then apply the hammering pressure. Then it becomes easy to shape the material to the desired shape. Now, as on the basis of temperature, forging can be classified in two ways. One is hot forging and one is cold forging. Now, if the temperature is above the plastic temperature or critical plastic temperature, it is called hot forging. And when the temperature is lower than the that plastic temperature or is working at a room temperature, it is known as cold forging. Cold forging is for very soft materials like aluminium, or we want to do very little amount of deformation, then cold forging is applied. Now this is the main classification, main classification of forging. One is open die forging. This is open die forging, and closed die or impression forging. Closed die also known as impression forging. As you can see, these two images, these are the examples of open die forging. These metallic parts, the lower and upper, these are Are the slides visible to all?
Sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. So these two metallic parts are known as die. Die is used to give a desired shape. We can to apply pressure as well as to give the shape. So in this open die forging, the die is actually open. It is two flat parallel faces, and between those faces, the object is placed and applied pressure, and desired shape will be given. And the material is free to flow in any direction. That is the main property of open die forging. And open die forging is used when the object size is very large. You know, this, you can see the object size is very large, and step by step it will be increased. It will be done throughout the length. So this is the open die forging, and as the size is very large, the number of components will be also very less. That will be produced in this. In impression or closed die forging, the size is very limited because it is completely enclosed within a die. You can see impression is made here. An impression is already made here, and when you put any form of heated raw metal and you press using this above die, it will attain the shape of this impression. So this is also known as closed die or impression forging. You can see here, like this is a closed circular die where when the raw material will be pressed, this will attain the diameter of this die, and we can get the desired shape that we want. Like this is the example. It is the connecting rod of the automobiles. So this is the impression or closed die forging and open die forging. So open die forging, it is performed between flat dies, two flat dies, like I showed you previously, two flat dies, and there is no pre-cut profiles. There is no profile. The material is free to flow in the direction, all directions, right? When you compress it in the thickness or width, it will free to flow. So there is no pre-cut profile, no determined shape, predetermined shape. Here the parts are of very large size, that is in weight as well as in length. You can see 200,000 pounds and 80 feet in length. It can be hammered or pressed into a shape. Now, as the size is very large, the components will be less here, and the size of the component is too large. It is used for where the size of component is too large. This is the schematic diagram. You can see the upper die, the lower die, a pressure is applied from above, and this is the billet. The heated material or raw material is known as billet, and it is pressed to get the final shape. This is also a process, the diagram which is showing the complete process. Initially, the starting stock was like this, and this is cylindrical form, and this is the upper die and lower die. And when the pressure is applied, this is a preliminary upsetting process. What is upsetting, we will learn in the coming slides. So initial upsetting, and this is a final, when progressive upsetting or pressure is applied, this is the final dimension we will get, final process, final product. Now, impression closed die forging, already I showed the images that it contains pre-cut profile. It will contain the pre-cut profile of the desired part, whatever, and it has very close tolerances. You can achieve the required dimensions that you want, as compared to the open die forging, where the material is allowed to flow freely in all dimensions. here the flow is restricted to up to a certain limit of value of dimension. So you can achieve a very accurate or very precise dimensional accuracy you can get. Now, because this is a closed die, so size is restricted. Very large sizes cannot be used here. Only up to 60,000 pounds it is used right now. So, okay. So in impression die forging, two dies are brought together with the workpiece and which undergoes plastic deformation. Now, this is very important point that all the deformation that is occurring is in the plastic state of the material. It is not in the elastic range. You all you must have read the stress strain curve of various materials. Have you all?
Yes, sir.
Right.
Yes, sir.
So there is a point beyond which the plastic deformation starts. Can anyone remember what is that point called?
Breaking point.
Sorry?
Breaking point, sir.
No.
Elastic limit.
Yes, elastic limit.
Yield point.
Yes, yield point. It is yield point. Elastic limit is beyond where the linear elasticity stops. Linear relation between the elasticity stops, but still the elasticity is there. But it is the yield point where the plastic deformation starts. So when we heat the temperature, the elastic point decreases. So very at low pressures also you can deform the material. Okay. So this is, you can see the schematic diagram for impression die forging. This is a pre-cut, you can say this is a pre-cut dimension that we want from the cylindrical billet. This was the initial billet that was used. Then the preliminary upsetting process, at the starting upsetting process is start, and this is the final product that we get. Now, generally, a small amount of metal generally comes out of here, but it can be machined later on. It is also known as flash. This is generally the flash, known as flash, which comes out of the die. Okay, so it is it is very thin actually. Here it is shown very thick, but actually it is very thin, a very small amount. It can be removed very easily. Now, forging, what materials we use in forging? So for forging, to learn about forging materials, we should be know about forgeability. This forgeability is the ability of the material to get forged. Every material cannot be forged. Every material that we see, every metals that are not forgeable. So what properties decides that the material can get forged? So it is the ductility of the material. What is the opposite of ductility?
Brittle.
Yes, it is brittleness. So ductility is a property where it can be made to stretch without breaking up to a certain limit. So where the ductility is high, actually the ductility and forgeability is directly related. It is directly related, as forgeability will increase as the ductility will increase with temperature up to a point of the second phase appears. Okay, this is forgeability increases with temperature up to a point at which a second phase appears. After that critical temperature that was I was talking previously, it is a critical temperature after which the phase completely changes. It is actually a microstructure change, so we'll not go into that deep. Some of the metals that can be forged are used in industry like carbon steel, alloy steel, wrought iron, copper-based alloys, Wrought iron is basically the iron which is formed through some processes, cutting or forging processes, and another is you must have heard is cast iron. Cast iron is the iron which is made through casting process, and wrought iron is very pure iron, nearly pure, which is made through the process of forging or other process other than casting. So aluminum alloys, magnesium alloys, all are very easily forgeable. Low and medium carbon steels are also easily forgeable. Okay, but then it was that this line was shifted here. But the brittle after this was here, brittle metals like cast iron cannot be forged. I had shifted this. So these are the metals that can be very easily forged. Carbon steels, alloys. You must remember 2 or 3 names from this for the in purpose of Viva when we ask. So now all metals cannot be forged. Like the metals actually which are brittle, like cast iron. Cast iron is very brittle, so it cannot be forged because it will break when you hammer it. Forging is a process where you continuously need to hammer or apply pressure to presses, mechanical presses. So cast iron is very brittle, so it cannot be forged. Now high carbon steels, alloy steels, are also brittle in nature. Actually, it is very difficult to forge. Low and medium carbon steels, where the carbon content is low, there forging is easy, but at high carbon stages it becomes difficult. Now, various components that are produced in industries are like connecting rod. This is the connecting rod, which is used in IC engines to transmit the power from the piston of the chamber to the connecting rod, which is finally connected to the wheels. Then crankshaft is another part which is used in automobiles. Leaf spring is this. You might have seen this in the lower portion, in the chassis of the trucks. Leaf spring is used in the chassis of the trucks generally to support the structure of the heavy vehicles and it is a very high resilience strength. So a very high strength materials are produced from forging. Forging produces the products which are of very high strength and which transmits power, and so such products are generally produced from forging. Now we will discuss about the various tools and equipments that we use in forging, like anvil, swage block, tongs, hammers, chisels, hardy, fullers, swage, flatters, punch and drift, and set hammers. So we'll go through all of these one by one. So anvil is a tool you must have seen at various places where blacksmiths use this very commonly. So the front part of this anvil, this is actually a supporting device. When you are hammering it, you use this as the supporting tool. And we also use there is some provisions in this anvil which may help you in deforming in a very specific shape. Like there is a circular hole known as hardy hole. There is this is a square hole. This is a pritchel, which is a circular hole, and then you have this beak or horn where you can shape the circular curvature. Okay, then various operations that we perform, it is performed on the anvil. So it is made of wrought iron or mild steel. Okay, this material is made of mild steel or wrought iron. Now a tool steel plate is welded on top of the body to protect it basically from the hammering process. Now the front portion is known as the horn or beak. Horn or beak. It is used for bending or forming the curved shapes where we need to curve. Suppose if we wanted to bend this rod, we would place here. This is the option that we can place here and then apply pressure. It will bend. Then the back part is known as the tail, and this tail carries two holes. One is called Hardy hole, and one is called Pritchell hole. Hardy and Pritchell hole. Pritchell hole is of circular shape. These we will go in the following slides. How do we use actually the Pritchell hole and the Hardy hole? We can use some objects to hold their hand and to bend it or form it, or to give it a square shape. The cross section we want to make square shape, okay, or any attachments that we want to use. Now this anvil is generally of 100 to 150 kg, and the standard the stand that we use is 0.7. It is not directly kept on the ground. It is kept on a stand. It may be a wooden or cast iron stand, and it is from 0.75 meter from the floor. Another tool that we use is swage block. Swage block is generally made of cast iron. It is made of the cast iron, and it has, you can see, very predetermined shapes like square, rectangle, circular, and you can see half round grooves, maybe roofed or some trapezoidal like shapes. These all are used to give some specific shape to our raw material. Suppose you want to give some circular shape, proper circular shape, you can place it, rotate it, and applying pressure. Or you can want to give some shape like a flat shape, or like a trapezoidal shape. There you can use it. So swage block is useful for holding bars while bending and knocking up heads. Like when you are preparing nails, you need the heads to knock up. It is used mainly for squaring. You want to make the cross section square, you want to bend, or punching operation, or size, you want to give specific sizing, or any forming operations. So swage block is very useful in that case. Now tongs. Now tongs is a very important tool that we use because it is used for actually gripping and holding the material which is at very high temperatures. We cannot hold it directly with hand, obviously. Even if using while at cold temperatures, we need to use tongs, because a very huge pressure is applied while hammering. So to make it stable and give it proper gripping, we use various types of tongs. Now, on the basis of application, various types of tongs are used. As you can see here, this is a flat tong. Flat tong is used where we use flat plates, flat objects we use, and which is not very large in size, but small, not very thick and not very huge in length. This is used flat tong. Now flat mouth tong, it is used for very longer objects, which is longer flat objects. Okay, so this is also known as two-sided supporting tong, because one support is getting from here and another is from this end. So two-sided support of flat mouth tong. Next is a square hollow tong. Here it is very easy to support the triangular or square form of materials to hold the square or triangular shapes. Then we have chisel tong. Chisel tong, it is helpful in holding or gripping the unsymmetrical objects which are not symmetrical actually. Then single supported tong. The single supported tong is used for holding flat objects with larger width. Here it was for smaller weights, but if the weight is very large, then this single supported tongue is used. This is the round hollow tongue. It is used to hold the circular objects, round objects in parallel direction. And next is pioneer tongue, which is used to hold the circular objects in perpendicular direction. Now this is the pickup tongue. It is used for supporting and gripping of small objects. Very small size. It requires more firm grip. So this is used for small objects. Then there is a very common household tool that is used and very important in the forging, and because forging itself the main process is the applying pressure, which is applied using hammers. If we use this is a hand hammer, where the pressure is applied using the muscle power. Another is power hammers, where the muscle power is not used. The power is taken from steam. The power sources can be from steam or electric power source or mechanical other drive forces. So in hand hammer, these are the main descriptions. This is circular portion is known as pin. There is an eye hole to hold the handle, and here we have the striking face through which we strike apply the pressure. Pin is also used to strike to give pressure, but generally it is used to give to work at corners or to give some specific shape. We use pin. So it is a very common, we have seen. This is power hammer. Power hammer, you can see, like I have video here. Now this person is producing a bolt made from this rod. Now you can see this is a hammer. Is this video? You can see this video.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now this should not be misunderstood as the press, because press is a continuous where continuous pressure is applied, but this is intermittent pressure, or you can say just like a hammering. This is a hammering process. This is a power hammer. Don't get confused with the presses. Electric power is used to move this electric power hammers. So this is actually he is using to make some nails out of this. So there are various types of hammers used according to the shapes, and it has different applications also. One is called ball peen hammer, where we have the peen is of round shape at one end, and another we have the flat surface. This we use for basically for riveting purpose or chipping purpose, and the weight is generally 100 to 900 grams. Then we have cross peen hammer and straight peen hammer. Now there is a this, you can see that is a cross pin. You can see this is perpendicular to the direction of the handle. This end is the perpendicular to the face of the handle. Then, and here in the straight pin hammer, it is parallel to the face of the handle. Handle will be placed in this direction, and it is parallel to this. And here the pin is also flat in nature. It is not circular. It is not round. So now where it is used? It is used in stretching and bending operation, and it is of 200 to 900 grams. And in straight pin, it also stretching and pinning purposes are used. Now sledgehammer, here both the surfaces are of striking faces, both are parallel, and it is for use for heavy work. Heavy work it is used, and it is a very the weight is also very high. 2 kg to 10 kg weights are used in the sledgehammer. The next is chisel. Chisels is used for cutting purposes. You must have seen at homes also there are chisels are used. Ways you must have seen when construction purposes are used. Chisels are used to cut some metals or any material. So according to the temperature, as per the temperature, two types of chisels are used. One is called hot chisel and another is cold chisel. Difference is the angle that is being made by the two faces of the chisel. This is 30 degree in the hot chisel and 60 degree in the cold chisel. Okay, so it is used with the handle, or we can use a very steel clamp. This is a steel clamp or rod also we can use. So it is made of medium carbon steel or high carbon steel, and the angle is kept at 30 degree in hot chisel. So hot chisel is used where we use metal in plastic stage. Metal in plastic, that is at higher temperature. And in cold chisel, the length of the cold chisel is more than the hot chisel. So this is a hot chisel. Hot chisel. It is made of high carbon steel and high angle. Here it was used of medium carbon steel, but this is of high carbon steel. High carbon steel is of high strength than the medium carbon. And cutting angle is used 60 degree. And there are various types of it is specifications, various different hot chisels you can get as per the different width and length as per the requirement. So chisel is used for cutting process. And next is the hardy. Now you remember the hardy hole that I mentioned in the anvil. This hardy is placed in the lower portion of this hardy. This is actually a tool used for cutting, where the lower portion is fixed or supported in the hardy hole, which is in the square form. This is known as the lower shank. It is fixed in the hardy hole of the anvil, and we can use it for cutting process. You can place the metal over here, and then we'll apply the pressure from above. Then this will tend the material to cut it. So we can use for cutting purposes. The hardy hole is used like this, or it is not necessarily always cutting. If anything in the form, if you want to give a different shape, suppose a circular shape, agar ye upper portion एक circular shape में होता, we want to cut in a circular portion, then the upper part will be different, but the lower part is in the similar form because it is used to support in the anvil. Then we have set hammer. Set hammer is basically used to flatter, to give flatness to the surface. Once all the shaping process is done, when we convert the give the form, then finally the finishing of the surface is done, then we use set hammers. Now set hammers are basically not very large in shape. For that we use flatters, but at the corners and at the places where the flatter cannot be reached, there we use hammers, as set hammers, to give finishing to the product, surface of the product. Then we have fullers. Fullers are the material where we use to neck down the cross section at a particular location. Suppose there's a huge, suppose there's a raw material, but at a particular length we want that the cross section must be neck down. It should be reduced. So we can use this fuller. Now again, this this bottom portion would be put in the hardy hole of the anvil, and the above portion is used with the rodded handle or wooden handle, and the material is placed in between it, and we can apply pressure, and the size at that particular part will be reduced to the required dimension. So fullers are the material that when you are asked about what is fuller, then you must remember the first thing that it should use for necking down or reducing the cross section of the job. Then swage. Earlier we discussed about swage block, but this is swage. So swage and swage block must not be confused. Swage is just like fuller. जो हमने previous slide में discuss किया, it is fuller is used to reduce at a particular location, but in a swage throughout the length, if you want to reduce the dimension, you can want to like here it is shown to reduce the diameter, because this will form a circular cross section. So swage is used to reduce the length, decrease the diameter, and at the same time it will increase the length. At the cost of the diameter, the length will increase. Okay, so this is the swage operation that we perform using the swage tool. Again, like in the fuller, the lower bottom portion is fixed in the hardy hole of the anvil, and the above through hand muscle power we apply the pressure using the above top portion of the swage. Now flatter is same as the set hammer, but is of higher. You can see the area is very large. This can be used in a large portion to smooth the surface, to make the surface smooth after the shape is given. After the complete shape is given to our product, we use flatters to give the smoothness to the surface. It is made of high carbon steel and well hardened. Hardening is very important because when you apply pressure, it is possible that the tool might see may get some cracks, or the surface of this might itself can get scratched or deformed. Then it will not be able to give smooth surface. So the surface of this tool itself must be hardened enough to give the proper required smoothness. Then punch and drift. Punch is a very common tool that we use to produce holes in the surface, in the object. When temperature is raised, we put the punch and apply pressure from above, and this can create a hole of a particular dimension in the object. Drift is the next part after punching. Of the process of punching, we use drift. Drift is more precise. It will give higher tolerances and expand or give the accurate dimensions to the hole, which was produced earlier by punch. So drift is actually to give accurate dimensions to the hole, or to improve the quality of the hole, to give more circular in nature. So we have done with the tools that we have used. Now this is the important aspect in the forging or smithing, is the heating devices that we use, because heating of the material is very important here, and to know the various type of heating processes is also very important. So these are the conventional types. You can see it was used by blacksmiths earlier days. It used and even today when you visit any blacksmith, you will be using such type of furnaces. This is simple box type furnace, where he puts the blacksmith will put the fuel, that is some coal or using some gas or anything, and he will put the stock or your the raw material directly into the furnace in that box and heat that object. Another is rotary hearth furnace. Now here it was simple box type, but now the furnace can be rotated also. If the object is such that very large, then he can use a rotary hearth furnace. He can rotate the furnace at different rotations, and he can use the heat efficiently. Next, continuous or conveyor furnaces. Now, similar furnaces, but conveyors are used. Conveyors are used as on a length of the over the heating chamber or heating surface. So now this is induction furnace. It's used very widely nowadays. Induction furnaces, and very prominent also resistance furnaces. These are based on the electric power. Induction furnaces are basically where the electromagnetic induction is used to heat the material. There is a chamber, and around the chamber coils are made, and within we keep our product in the chamber, and the electricity, when the electricity is passed, the electromagnetic induction will induce the metal to get heated. So induction furnaces are, and it is very easy compared to others because a single person can do this. Not many persons are required to charge the furnace, and another is taking out the material. And next is the resistance furnaces. Resistance furnace और इसमें क्या फर्क है? Resistance में जो आपका material है, it itself becomes the part of the circuit, and it is very fast. It is faster than induction furnaces because the induction process takes time, but your material itself becomes in the part of the circuit. So resistance furnaces are more quick in nature. So now these are the various forging temperatures or the plastic temperature after which you can see the plastic temperature is attained in different materials. Suppose if you are using wrought iron, we can achieve the temperature is between 850 to 1300 degrees. The temperature must be within this for forging. And aluminium, suppose it is 300 to 850, aluminium magnesium alloys 300 to 850 degrees. And for mild steel it is 750, 1300. So with the various materials that are used in the forging, and these are temperatures at temperature range that is range at which the material will be easily forged. Now next we see the forging operations. Forging operations that we can perform on the material to give a particular shape. Forging operations. There are various forging operations. You can see offsetting process. This was the offsetting that I used the term before also. Drawing down, setting down, bending, cutting, punching, drifting, fullering, and welding. Yes, forging was the first the process that was used for welding. Earlier there were not the welding processes, the welding process that we use nowadays. Forging was the only process, even 150 years back, was the only process that was used for welding. So we'll go one by one through all the processes. Offsetting process. Offsetting is the process where we increase the thickness of the material, You can see here increasing the thickness or cross section of the material at the expense of the length. Length is reduced, we apply pressure across longitudinally, and we increase the thickness of the material. This process is known as upsetting. Wherever we increase the thickness, this is the upsetting process. We apply the pressure longitudinally, and there is an increase in the cross section or the thickness, also known as the jumping. Upsetting is also known as jumping process. The metal is heated up to a plastic state, and then applying the pressure using the hammer. After we support the material, the metal tends to increase in its dimension at 90 degree to the direction of application of force. Now, application of force, if this is in the negative y direction, so is in the y direction, then the deformation we get in the perpendicular x direction. So there is a 90 degree between the force and the increase in dimension. Now, upsetting process can be of 4 types. They can be of 4. We can do it in 4 different ways. One is when upsetting is done to the entire depth of the material, entire depth. The entire thickness of this material has increased, entire thickness. So this is where throughout the depth the thickness has increased. Second, upsetting, where only the edges are being upset. Here only the ends are upsetted, and here why this upsetting is not done, because we do not heat here or we cool down at this process using water. We use water or we don't heat, we just heat here and here, and we put it on the anvil and apply pressure. Only this here the thickness will increase. Now, upsetting can take place only at the lower portion. If we want at the lower portion, we can heat only this material, or we can cool down the other and apply pressure. Only here the upsetting will be seen. Or opposite, we want only in the middle portion. That also we can achieve by only heating this part, and remaining the part will be at the lower temperatures. So no upsetting will be seen in the other portions. So these are various types of upsetting process. Then drawing down. Drawing down is opposite of this. Here you can see the length is increased. Length is increased, but thickness is decreased. Thickness or width is decreased. Earlier the width or thickness was increased, but here the width increased and the width decreases and the length will increase. Length of the material increase at the expense of its thickness or width. It is also known as swedging process. Earlier one was known as the jumping process. Upsetting was known as the jumping process, and drawing down is known as the swedging process. It is exactly reverse of upsetting. So if this was the original metal, then we using of this hammering, we decrease the length, and then we have using the flatter, because after giving this desired shape, we need to improve the surface quality. So we give using the flatter, we improve the surface quality. So this is the drawing down operation, where we decrease the thickness of the material. So what discriminates between these processes: in upsetting, we increase the thickness at the expense of length, whereas in the drawing down we decrease the thickness and increase the length. Now, setting down is very simple, similar to the drawing down operation, but it is localized. Suppose it is not, we want to do at a particular location at a very particular point, then drawing down, it is called setting down. Suppose at the corners we want to do, only at the corners we want to do at a particular point, then it is known as the setting down process. Now this bending is also very important part of this operation. Bending we can use is very prominently used in various type of metals to give a curvilinear shape or angular shape. Two important shapes that are given is curvilinear or angular shape. A sharp angle is used. Now for curvilinear, what we do, we place on the horn or the beak of the anvil or the front part of the anvil. We place over here and we apply pressure, like this is the steps. We apply, put the metal on the anvil and we start applying pressure, and finally we bend it. So bending operation can be classified as curvilinear and angular bars. In angular, so bars and flats are bent into required shape using bending operation. Bending is done on the anvil face, over the anvil horn, or on the front, is also known as the front face, front part of the anvil. Or we can also do this bending on the swage block. Swage block जो हमने discuss किया था, we can put the metal on the swage block and perform the bending operations.
सर हेलो
Yes.
सर आपकी वॉइस क्लियर नहीं आ रही, पीछे से आवाज आ रही है कुछ,
Okay. So
वजह से।
so now अभी clear है आवाज?
नो सर अभी भी आ ही रही है बीच बीच में, कभी कुछ कैसे कैसे अजीब सी।
नेटवर्क तो ठीक है, नेटवर्क प्रॉब्लम तो नहीं आ रही है, कुछ डिस्टरबेंस?
सर नॉइज आ रहा है साइड से, बस नेटवर्क प्रॉब्लम नहीं है सर।
अभी आ रहा है? अभी तो मुझे तो कोई नॉइज
अभी
फील
नहीं आ रहा सर, अभी नहीं आ रहा सर।
अभी नहीं आ रहा। ओके, जस्ट गिव मी अ मिनट। Okay. So now is it fine?
Sir.
Yes, sir.
Okay. We have done this. So bending process, we can use, we can do it using on the anvil, on the front part of the anvil, or using the swage block. We can hold or support the material on the swage block and then apply pressure at the location or at the position that we want to bend it. Now while bending, what happens? The inner surface gets compressed, sees the compressive stresses, and the outer faces will undergo the tensile or stretching. It will see the stretching state of stress. It is the compressive stresses, and at the above end we get the stretching it. So we require it to do the bending in various steps. We should not go step by step. We should hammer. We start from here, then we push it in forward direction, then we start hammering like that. So a gradual in gradually we attain this shape, not in a one go, because there is a continuous compression and stretching we see across the length of our product. Now angular, for angular we can use the corners of the anvil or the swage block to place it at the edge and then hammering it to the particular angle that we want to get. Again, after the bending process, flatter is used. Flatter or set hammer is used. Set hammer is used inside of the edge, and the flatter is used on the outer side of the edge. Okay, because set hammer is of the smaller dimension and we can reach it inside of the bending inner portion of the bended portion, and flatters we can use at the outer portion of the bending surface. Now cutting operation, we can do cutting at both at the hot stage and at the cold stage. We can use both chisels. Basically we use chisels, hot chisel or cold chisel. Okay, so cutting operation is used when we want to reduce the length of the material, or we want to notch up some material at particular location. We want to cut it into several pieces of the length, or extra material we want to remove from the material. Then we use the hot cutting process. Generally the hot cutting process is used for it. Cold cutting is used, we want to cut the thin surfaces, where we see thin surfaces or round sections. Then we can use the cold cutting process and it can be done easily at it. Now there are various temperature ranges where different colors will appear on for the material. From starting, you can see there are orange, or when you start hitting the steel, you will see various colors: brown, orange, red, yellow. Every color will signify a particular temperature. So light cherry red heat temperature corresponds to 850 to 950 degrees Celsius temperature. This is used when we use the cutting process of the metals. Then we have punching and drifting process. In punching, we produce holes in the objects. For this, we first heat this material. This is our material. We heat our material up to a particular certain temperature, and we place it on the you can use the anvil where the hardy hole is used. You can use the holes in the hardy or the swage block also. You can place it on the swage block like this, and using the punch you apply the pressure. Then this shearing operation takes place. The material gets sheared from here. Generally, this cutting and punching process are also known as the shearing process. When you cut, suppose when you cut using scissor, so that process is known as shearing process. Why? Because the layers at this end and this end, they move in the transverse direction. So this is a shearing process. When the blade of the scissor it moves in the opposite directions. You must have seen, if you observe closely, when you use scissors to cut the paper, it will move in the transverse direction. One moves if lower, then the upper part goes in the above direction, and this gives the shearing operation in the scissors also. Similar operation is happening here. Suppose this is the one part of the scissor and this is another part of the scissor. If we see the relative motion between these, this will move in the lower direction, this is moving in the upper direction, and this is giving the shearing operation to the punching. So whenever you ask to what method it is cutting and punching operation are going, so it is a shearing of the metal, also known as the shearing of the material. So material is sheared out or punched out through this hole, and after punching is done, then we use the drift tool for drifting. Drifting is used to give proper accurate dimensions, accuracy, to improve the accuracy, because while punching there may be, because we applied large pressures, there might be the edges or the edges might not be in the right form, right, there may be some deformed at the edges, so we need to use drift tool to give better surface finish or give better dimensional accuracy to the hole. Then fillering. For fillering, we use the fuller tool. So as I discussed before, the fuller tool. You remember what is the fuller tool? मैंने थोड़ी देर पहले बताया था. For what it is used? Anybody?
Necking down the surface.
Yes, very good. What is your name?
Sir, Samyak.
Samyak. Okay, very nice. The fullering is fuller is necking down of the material at a particular location. So we use fuller set. मैं आपको दोबारा दिखा देता हूँ, काफी लोगों को याद नहीं है. These are fullers. This is a set. Wait a minute. This is a set of two tools. One is placed in the anvil, in the hardy hole of the anvil, and another we use mechanically with hand. We apply pressure. It is used for necking down, necking down of the object at a particular location. Okay, so this process is operation is known as the fullering process. Fullering process. The length of the workpiece is increased if we follow the volume constancy, because the volume will be constant. So if the diameter is decreased or the thickness is decreased, so the length will increase at the cost of the width. It is also known as the drawing process, because the length is increased. That is known as the drawing process. So fuller set is used in this process. Hot metal is placed over bottom of set of the fuller, which is placed on the hardy hole of the anvil, and the hammer blows is directly provided on the metal or the top surface of the fuller. Next operation that we perform in forging is welding. Welding, we can weld metal through forging by directly applying pressure to the metal. If we put two metals one above the other and both are heated to a particular temperature, and you apply pressure, there will be a mechanical joining process will occur at the microstructure level or the micro level, and the objects are welded actually. So two pieces of same metal are heated, joined together with external pressure, so they may act as a single one. The metal pieces are heated in the smith's hearth or the furnace to the welding temperature and then withdrawn from the furnace. These metals are joined together by application of external pressure through hammering. Now, while welding using the forging, one problem occurs, that is the oxidation of the surfaces. The surface of the metal at higher temperature get exposed to the environment, and scales of oxidized scales are formed on the surface, and these scales that are formed, these very thin surface that is formed of oxidized layer, is very harmful for the welding process, because then the welding strength would not be good. So common fluxes we use, some fluxes are used in welding. We can use sand while heating. We can use sand or with wrought iron, or we can apply a very little and very little amount, not very high amount, and we can apply borax powder on the mild steel. So this will reduce the chances of the, or completely eliminate the chances of oxidation on the surface. So this will give a sound welded joint, surfaces that come into contact. Now these surfaces must be clean from any scale, from any dirt, ash, or anything, otherwise it will lead to the failure of joint. So 4 different types of welding joints are used: butt weld, lap weld, T-weld, or split or V-weld joints. So different positions at which the material can be placed. Butt weld, very common type of the welding edge. Basically these are known as the edge preparations. How the edge is prepared to weld. The process is very similar in in all of this welding process. The process is same, but only the edge preparation is different. One is butt, end to end joining is done. This is known as the butt welding. Here the metal pieces are joined together end to end. End to end it is joined. We increase the when we start applying pressure, some increase in the thickness will happen, and finally it will join also. It will join, and we can hammering, we can level out the thickness of this material. Next is lap weld. Lap weld is an angle is given between rather than the perpendicular surfaces and an inclined direction. The welding is done in the inclined direction, and we join the faces of this both, and we apply pressure from both sides. We place it from below and apply pressure, and the joining process is done. So the welding joint is in the inclined direction. Then we have T-weld. We will also go various types of welding techniques and welding positions when we study the welding shop. So various other welding positions we will also see: horizontal, vertical, overhanging. But within the context of forging, we will only see these 4. So one is T-weld, where the piece is placed, one piece is placed in the center of the another, and it is placed in the form of inverted T. And then by applying pressure at these 2 points from here and placing from beneath, the welding will be done. Then we have V-weld. V-weld, here the welding ends are made in the form of fork or tongue respectively, and this is most secured form of joint, most secured form, because when we apply pressure at here, it is chances that some slipping might be possible, some misalignment may be possible in here also when you apply here, and here also misalignment is possible. But here when we use we cannot most secured and very accurate welding we can see in the V type of when edge is used in forge welding, and it's also the strongest joint using the forge welding, strongest joint. So these were the some of the processes that are used in the forging. Now next step after the forging is done, when we start with the forging, we heat the material first of all, then we take to the anvil and we form it any desired shape, and after when a particular shape is achieved, we use some flattening tools to smooth the surface, to make the surface smooth, and after this we do heat treatment of the object. Now why heat treatment is done? Because in the forging, continuous hammering of the metal is done, and this will tend to some internal stresses that are withheld within the surface. So to remove this internal stress, we need to make the material go under heat treatment, because it will otherwise the metal would be more brittle, not completely brittle, but to a certain degree the strength will not be there. The brittleness, the strength will be there, but it might fail very quickly. So to remove this internal stresses and various other microstructure properties also, we do heat treatment process after all the process has been done. So finally, even in the industries, what it is the common practice, when all the, even in the automobiles or anything that we produce, when after all the forming operations is done on the metals, and before like in automobiles also, before painting it, we give some heat treatment to the metals, so that all the internal stresses and to improve the other properties, heat treatment is done. So what is heat treatment? Basically, heat treatment is heating and cooling of the metal in a controlled atmosphere, where we control the heating and cooling, not only heating but the cooling of the atmosphere in the solid state to get the desired properties. The cooling rate is also predetermined in it, because it plays a very important role in it. You must have heard about quenching or annealing, right? So what is different between quenching and annealing? ये आप लोगों ने 10th लेवल में पढ़ा होगा. Yes, anybody? Can you hear me?
Yes, sir.
हाँ, तो what is the difference between quenching and annealing?
Sir, what quenching and
Annealing.
Sir, in quenching,
With
so
respect to
annealing is done at a higher temperature.
Okay. Quenching.
So quenching means heat treating the object and then putting it into oil.
Okay, oil or in water. So the cooling rate is fast. Basically, what we want when we put in water, what happens? The cooling rate is so fast. In a matter of seconds, the metal will cool from even from 1000 degrees Celsius to room temperature. But in annealing, the temperature cooling rate is not so high. So in both the cases, the outcome, if we two products, same material, same process, but at the end we use water and one we use a normal cooling, so the end product will be different. Okay, so heat treatment gives different products. So various types of heat treatment are there, but the objective of heat treatment are to relieve the internal stresses, to change the grain size. These are all microstructure changes, to improve the machinability. It increases the resistance to heat and corrosion. It increases the corrosion properties, electrical magnetic properties, chemical properties, mechanical properties. ये सब increase होती हैं, improve होती हैं, strength, ductility, hardness. So various type of processes of heat treatment that are used in industries like annealing, normalizing, hardening, tempering, and case hardening. Annealing is done when material is heated to a critical temperature and then is allowed to cool it slowly. Slowly, it may take 4 hours or 5 hours to cool. The purpose of this is to relieve the internal stresses, refine the grain size, and to make this metal soft. Another is normalizing. You must remember the names at least for this, all these. Normalizing is done to heating the material at a particular critical temperature, 50 degrees above the critical temperature. It is a critical temperature which you will read in the when you go through the microstructure and study. So there is a critical temperature 50 degree above the temperature for a given period of time, and the important part is it is cooled in air. It is cooled in air. This is again to remove the internal stresses, refine the steel. In hardening, again we take up to the 30 to 50 degree above critical temperature, but we cool suddenly here. It was allowed to cool in the air here in the normalizing, but in hardening it is cool suddenly in liquid. We put in liquid, so the surface is hardened. The surface of the material gets hardened when we do this type of process. We suddenly cool it. This process is also known as quenching. Okay, so this operation of hardening हम यूज करते हैं जहाँ हमें टूल्स बनाने हैं, कोई इंपॉर्टेंट चीजल्स बनाने हैं, टूल्स. So we use this hardening process over there. Another is tempering. Again, in tempering, the material is heated to a suitable temperature, but below the critical temperature. And यहाँ पे above the critical temperature था, but tempering is below the critical temperature. Then it is allowed to cool slowly in air. केस हार्डनिंग में होता है कि जब हमें सिर्फ सरफेस हमें हार्ड चाहिए, बट इंटरनल वी आर नॉट कंसर्न मच. सो व्हाट वी डू, वी हीट द मटेरियल टू अ रेड हॉट कंडीशन and then force the carbon contents into the surface structure. We apply some carbon on the surface, so it will diffuse into the surface of the surface up to a certain depth. So the surface becomes rich in carbon. When the carbon content, the property of carbon is that it will give hardness to the metals, in steel specifically. When we put more carbon, the material gets hardened, more strength. So up to a certain depth, the surface will become hard. This process is also known as carburizing. Okay, so it is mainly used for mild steel and wrought iron. This treatment will produce very hard and fine grained case. Only the case hardening, because the outer surface of the block, suppose the cylindrical object is used, only the outer surface of the object is hardened, while the core of the structure remains as it is. It is not hardened to that particular temperature. So thank you. This is all from my side for today in this forging class. So any questions you want to ask? Any queries from today's class?
No, sir.
Okay.
सर एक बार मुकेश सर से बात हो सकती है, उनसे पूछना था कुछ.
हाँ मुकेश सर are you
बोलो.
Yes
बोलो क्या.
सर वो एब्स्ट्रैक्ट के बारे में पूछना था कि 2 लोग सेम टॉपिक ले सकते हैं, 2 बच्चे.
हाँ, 2 बच्चों का ग्रुप हो सकता है
सर. तो सर मतलब सर हम
मैक्सिमम 2
एब्स्ट्रैक्ट सेम लिख सकते हैं हम, और जो फाइल है वो अलग अलग बना देंगे, मतलब विद एग्जांपल्स और दूसरे उससे.
नहीं, दोनों का ग्रुप हो सकता है और सेम कंटेंट रहेगा दोनों का.
फाइल भी सेम सर.
हाँ, देखो एक ग्रुप 2 स्टूडेंट्स का हो सकता है, मैक्सिमम 2, राइट. बट दोनों का एक ही प्रोजेक्ट रहेगा. यू कैन टेक 2 एग्जांपल्स.
ओके सर. और वाइवा अलग रहेगा दोनों.
हाँ, वाइवा तो टॉपिक एक रहेगा, दोनों का वाइवा साथ में होगा.
अच्छा. ओके सर.
सर मैंने आपको एब्स्ट्रैक्ट भेजा था तो उसके अंदर आपने मुझे एक चीज ऐड करने के लिए बोली थी, तो सर मुझे वापस से एब्स्ट्रैक्ट बना के भेजना है उसे इंक्लूड करके।
हाँ, इंक्लूड करके भेजना है। अच्छा, आपको ना नेक्स्ट जो आपका लैब होगा, राइट, उसमें आप ये दे दो मुझे टॉपिक, राइट, एटलीस्ट टॉपिक। एब्स्ट्रैक्ट, इफ यू आर गिविंग एब्स्ट्रैक्ट दैट इज वेल एंड गुड, बट इफ यू आर फेसिंग सम प्रॉब्लम्स यू टेक अप टू नेक्स्ट लैब, राइट। अगर कोई इश्यू है तो मैं आपको टॉपिक दूंगा। किसी को
सर
चूज करने में प्रॉब्लम हो रही है तो
सर
मैं
आप
आपको टॉपिक
सर
दूंगा।
आप टॉपिक सभी बता दो, क्योंकि सर बहुत सारे बच्चों को सर कंफ्यूजन हो
नहीं
रही है
नहीं
सर, बस कास्टिंग ही
नहीं
चल रहा है
नहीं,
सर, मेन
मेरा क्या
कॉमन
है,
टॉपिक।
मेरा मतलब ये है नेक्स्ट वीक तक आप अपने एंड से सोच लेना, राइट। अगर आपका नहीं होता है तो नेक्स्ट वीक में मैं आपको टॉपिक्स दूंगा, राइट।
ओके सर।
आपको थोड़ा फ्रीडम देना है मुझे, राइट, आप अपना टॉपिक चूज करने के लिए। अगर आपको टॉपिक चूज करने में प्रॉब्लम आ रही है तो मैं आपको टॉपिक दूंगा, राइट।
ओके सर।
यस सर।
ठीक है, तो कोई स्टूडेंट्स को अपना फ्रीडम चाहिए टॉपिक्स चूज करने के लिए, दैट फ्रीडम ही विल मींस टेक। तो ये अभी स्मिथ शॉप नेक्स्ट वीक में आपको वीडियो दिखाया जाएगा, राइट, एग्जांपल्स थोड़े से, राइट।
सर
और आपको देखो टुडे इज 30, देन 6/13, राइट। ऑन
सर
13 यू हैव टू सबमिट दिस एक्सपेरिमेंट, 13 को, राइट। आपके पास 2 वीक्स हैं, राइट।
सर
यस,
सर कल हॉलीडे है ना सर?
कल हॉलीडे मुझे वो चेक करना पड़ेगा उसमें ड्यूटी की साइट से, राइट। तो नया ईयर है तो एकेडमिक कैलेंडर मुझे देखना पड़ेगा, हॉलीडेज देखने पड़ेंगे। शायद जनरली होता है, राइट, टुडे नहीं, टुमारो नहीं, 1 तारीख को होता है बेसिकली, फ्राइडे को रहेगा।
सर सर तो एक को तो आपकी क्लास ही नहीं है सर, आप 31st की दे दीजिए सर।
अच्छा, ऐसा नहीं है।
सर
कल क्या
लास्ट
है, कल आपका बीएमई का
सर
क्लास है
बी
क्या?
बी बी पार्ट की क्लास है सर।
हाँ हाँ हाँ, ठीक है ठीक
सर
है ठीक है,
हॉलीडे दे
देखते हैं,
दीजिए सर,
ठीक,
सब बच्चे कह रहे
ठीक
हैं
है।
सर।
आज तो क्लास है ना, आज क्लास है, आज क्लास में क्लियर कर दूंगा।
हाँ ठीक है सर, आज
हाँ,
कर लेंगे, कल हॉलीडे कर लेते हैं।
ठीक।
ठीक है।
और कुछ डाउट्स है तो सर से पूछो।
सर ये स्मिटिंग शॉप की पीडीएफ दे दो।
हाँ, पीडीएफ मैंने ग्रुप पे दे दी है, राइट। आई विल पुट ऑल दिस मैनुअल्स इन क्लासरूम वन बाय वन, राइट। तो ये दो मैनुअल्स है, मैं अटैच कर दूंगा क्लासरूम पे।
सर
यस,
सर ये हम पीडीएफ या उसी के आगे कंटिन्यू कर देना, या फिर न्यू फाइल लगेगी? वैसे उसी के
नहीं
आगे कंटिन्यू
नहीं
होगी।
नहीं, तो उसी उसी फाइल में लिखना है।
ओके सर।
सेकंड एक्सपेरिमेंट बोल के, मतलब सेकंड एक्सपेरिमेंट लिख के आपको स्मिथ शॉप आपको कंटिन्यू करना है
ठीक है
उसी
सर।
में।
ओके सर।
सर
Right.
इसमें जो आपने भेजा है उसके अंदर एक्सरसाइज के क्वेश्चन है वो भी लिखने हैं?
हाँ, वो भी लिखने हैं। एक्सरसाइज बेसिकली आपको रॉड को बोल्ट में कन्वर्ट करना है, राइट। सो दैट्स इज द प्रोसेस, राइट। तो आप कुछ डाई रहेगी, पंच रहेगा, राइट, जस्ट यू हैव टू हैमर इट, राइट। इज मे बी द कोल्ड, मोस्टली इट इज अ कोल्ड फोर्जिंग, राइट। उस पे आपको स्टडी करना है, राइट। तो आपका जो नट बोल्ट्स लिए हुए हैं जिनका ये है, हम्म, अगर प्रोजेक्ट ले रहे हैं तो यू कैन गो थ्रू दैट वन, राइट, यू विल गेट सम आइडिया, राइट। तो जो किसी ने भेजा है ना नट बोल्ट्स का एब्स्ट्रैक्ट, राइट,
यस सर।
तो उससे आइडिया लग जाएगा आपको, राइट।
सर मैं एब्स्ट्रैक्ट अभी जो मैंने आपको भेजा है वो रहने दूं, जो आपने एडिशनल पॉइंट्स बोले हैं वो मैं डायरेक्ट प्रोजेक्ट में इंक्लूड कर दूं?
हाँ, चलेगा।
ओके सर, थैंक यू सर।
और उसके लिए मैं क्लासरूम पे अलग सा ये एक्सरसाइज पुटअप करूंगा, राइट। तो उसमें आपको ओनली एब्स्ट्रैक्ट पुटअप करना है।
सर आप मुझे ना क्लासरूम का कोड भेज दीजिएगा सर, मैं
ठीक है,
डाल दूंगा
ठीक
ग्रुप
है,
पे।
ठीक है। ओ, और कुछ डाउट्स है तो पूछो, नहीं है तो क्लास क्लोज कर लेते हैं। अटेंडेंस, एक मिनट, अटेंडेंस ले लें। इसमें इसमें एक मेरे ख्याल से बैकलॉग वाला एक स्टूडेंट्स होगा इसमें, राइट?
यस सर, यस सर।
इसमें आया नहीं आया because roll numbers are not reflecting, that is again the problem.
सर मैं आपको एब्सेंटीज की लिस्ट भेज दूंगा सर, मैं ले लेता हूँ स्क्रीनशॉट।
हाँ, एब्सेंटीज की लिस्ट भेज दो मुझे।
ठीक है सर। ओके सर, बाय सर।